Hello students, hope you are doing well. In this video, we'll look into the next few concepts of the chapter waves and sound waves. The concepts that we are going to look into are speed of sound waves and stationary waves in pipes. First, let's look at speed of sound waves in solid. Now, we don't go for derivation, we'll just look at the expression and see what all factors does speed of sound waves in solid depend on. Speed of sound waves in solid depends on elasticity of medium and density of medium. So, speed depends on, I can say depends on, one is elasticity and the other is density of medium. The other is density of medium. These are the two parameters on which it depends. So, speed is given by root of elastic modulus y by rho. So, what is speed given by? Where y is Young's modulus of the material and rho is density of the material. So, this is what is speed of sound in solids given by. So, it depends on elasticity of the material and density of the material. Now, let's extend the same idea to speed of sound in liquids. So, again speed of sound in liquids also depends on density and this, but it is given by root B by rho. Now, here B is bulk modulus. So, only difference is what? It is bulk modulus, rest all is same. So, again so this is how we find out. If I know bulk modulus and if I know the density, I can find out what is the speed of sound wave in that particular liquid. After that, let's extend this idea of speed of sound wave to in gases. Speed of sound wave is given by V equal to gamma P by rho. Now, what is gamma here? Gamma is Cp by Cv, adiabatic constant. So, what all factors it depends. Now, there is something little important thing that you have to see here is, although the expression says V is equal to gamma P by rho, here P is pressure on the pressure of the gas. P is pressure and rho is as usual density. Now, although the expression says V is proportional to V equal to root gamma P by rho, velocity or speed of sound wave in gases does not depend on pressure. Now, why it does not depend on pressure? Because if I increase pressure, there will be corresponding increase in density also. So, whatever changes or pressure are there, they are nullified the changes in density. So, it does not depend on pressure. Very important thing to note that speed of sound in gases does not depend on pressure. Now, let's try to find out other expressions for that. So, I can write V equal to gamma P. P can be written as, we know PV equal to nRT. So, P can be written as nRT by V. So, let me put it here. So, I will get nRT by V by rho. So, V equal to, now this V is volume, don't get confused. So, speed equal to root gamma nRT by volume into density is mass. So, total mass. So, this can be further written as gamma RT by m by n. Now, m by n equal to m is molar mass. So, the final expression that we would get is V equal to gamma RT by m. So, speed is directly proportional to square root of gamma, adiabatic constant. Speed is directly proportional to square root of temperature. Here temperature is absolute temperature. Now, absolute temperature means temperature in Kelvin scale, and V is inversely proportional to square root of molar mass. So, these are the parameters on which speed of sound in gases depends on. So, depending on which parameter is given, we can find out what is the speed of sound in the gases. After this, let's look at stationary waves in open pipes. Now, what is an open pipe? An open pipe is a pipe which is open at both ends, something like this. Now the rules that we follow is, at the open ends, in fact just outside the open ends, antinodes are formed. Just outside open ends, what we have is antinodes. And so this is the rule that we use. So if I look at, if I blow air, let's say here, then what will happen? The disturbance travels from here to here. Now because the speed of the air here, there is a low pressure created. Because of the low pressure, there would be a disturbance coming in this direction. These two superimpose to form a stationary wave. Now I want to find the maximum possible wavelength of the wave that is possible. I'll draw something of this kind. I'll take the other color, something of this kind. So this is antinode, this is node, this is again antinode. The separation between node and antinode is, we know that it is lambda by 4. So this is lambda by 4. If L is the length of this pipe, I can write L equal to lambda by 2 or lambda equal to 2L. So my first harmonic or fundamental frequency is given by V by lambda, that is equal to V by 2L. So what is this? This is first harmonic or fundamental frequency. Now let me look at the second harmonic. I take the pipe, so I'll have something like this. So we have two nodes and two antinodes. So from here to here it is lambda by 4, lambda by 2 and again lambda by 4. So what do I have? I have lambda by 4 plus lambda by 2 plus lambda by 4 equal to L. So that will imply lambda equal to L. So I have second harmonic or first overtone is given by V by L. Similarly, if I talk about third harmonic would be the next possible wave. So if I have this one, I'll take the next possible wave to be something like this. So from here to here it is lambda, this is lambda by 4, lambda by 4. So lambda plus lambda by 2 is 3 lambda by 2 equal to L, or lambda equal to 2L by 3. So F3, third harmonic, is how much? It is V by lambda, that is equal to 3V by 2L. So in this way, what I can say nth harmonic is NV by 2L. These are, so the frequency produced by stationary wave in pipe is n times the fundamental frequency, which is equal to V by 2L, where V is speed of sound in that particular medium. Now this is about stationary waves in that are open pipes. Now let's look at stationary waves in closed pipes. Now what are closed pipes? Pipes which are closed at one end are called closed pipes. So the rule that we follow is near open end we have antinode. Now, and the other one, at closed end we always have a node. We have a node. So let me look at the maximum wavelength that can be produced. So I have a node and antinode, something like this. So this wavelength is, this is how much? Lambda by 4. Separation between node and the next antinode is lambda by 4. So I have lambda by 4 equal to L, or lambda equal to 4L. So first harmonic is equal to V by lambda, that is equal to V by 4L. I can call it as first harmonic or fundamental frequency. So this is what? This is either first harmonic or fundamental frequency. Now let me look at this next one. The next possible wave would be something like this. So from here to here it is lambda by 2, separation between two nodes, and this is lambda by 4. Don't go along the scale. So the total is lambda by 2 plus lambda by 4, that is 3 lambda by 4, which is equal to length. So what would that imply? Lambda equal to, I'll have 4L by 3. So next frequency I would say is equal to V by lambda, that becomes 3V by 4L. So we call it as third harmonic because the coefficient is third. Similarly, or the first overtone. Similarly, the next frequency would be 5V by 4L. So that becomes second overtone and so on. So here you can see that in case of a closed pipe, we only have odd harmonic. We don't have even harmonics. And one more thing that we have to remember in case of the formation of stationary waves or antinodes near the open ends are, antinodes are formed slightly away from the open end. Like if I have this as pipe, the antinode is formed somewhere slightly here, this part. Now this part is called end correction. So generally whenever we use it, instead of using length L, we use L plus E, so that extra part that is coming into picture is also taken care of. So this is about stationary waves in closed pipes. So let's have a quick review of what all things we have done. We have seen what is speed of sound in solids, liquids and gases. In solids and liquids, we saw that it depends on elasticity of the medium and the density of the medium. So it is under root of Y by rho in case of solids and under root of B by rho in case of liquids. When it comes to gases, we got the expression to be gamma P by rho, but surprisingly, the speed of sound in gases does not depend on the pressure. So what does it depend on? It depends on gamma, that is adiabatic constant, temperature, absolute temperature, and molar weight of the gas. After that, we saw stationary waves in open pipes and closed pipes. In open pipes, we saw that at the ends only antinodes are formed, and in closed pipe we saw that at the closed end we have nodes and at the open end we have antinodes. So the important things that we have to remember here is what? In closed pipes we only have odd harmonics, and in open pipes we have all the harmonics. Apart from that, antinode is formed just outside the open end, so there is an end correction that is included when I had to be very precise about the calculations of frequencies produced. I hope you could follow this. Thanks a lot for watching this video in specific and all other videos at Get My Class. So make maximum use of these videos and the questions that are made specifically for various competitive exams. So keep using Get My Class and reap the maximum benefits from that. Thank you very much once again.